Hello, and thank you for taking the time to watch this short video introducing the latest invention of Dr. Jamil Rima, the RWT21 technology for waste carbonization. RWT21 can be used in many applications, for example, the carbonization of municipal solid waste, slaughterhouse waste, most medical facilities waste, expired drugs, as well as the sludge collected from sewage treatment plants. RWT21 is based on a combination of three elements: pressure, heat, and catalysts. We'll show you during this video how these three elements interact in order to treat municipal solid waste or MSW. Please do keep in mind that the objective of this video is to showcase the RWT21 technology itself. The vessel, as well as the loading and unloading mechanisms used in this video, will not necessarily be the same in the commercial applications. These will be custom made based on the needs and requirements of the client. As you can see from this angle, the RWT prototype showcased here is made out of a special pressure vessel and 3 burners. The prototype is placed horizontally, but other placements are being considered to further decrease the cycle time. One of the catalysts is included in the pressure vessel and the other is injected with the air during pressurization. For this prototype purpose, the vessel is made to withstand pressure of 6 bars and heat up to around 500 degrees Celsius. Pressure is measured with this pressure indicator, while heat is measured with the help of 2 thermometers, one placed on the vessel itself to measure its own temperature, while the other is placed on the exhaust to measure the water vapor temperature. We start off by heating the fuel burners and loading the machine. There are several ways to load the machine, such as large hydraulic pistons or conveyor belts, but in our case, we used a silo equipped with a helical screw. The choice of loading mechanism will be based on the specific requirements of each client. The waste is emptied into a silo with the help of a bobcat. Then MSW is pushed into the machine with the help of the helical screw. The loading time will depend on the loading mechanism chosen by the client. In our prototype case, it took around 20 minutes. When the machine is loaded, pressure is added as well as the catalyst before the red burners are turned on. Once pressure reaches the desirable level, the fuel burners are fired up in order to start heating the vessel to the designated temperature. While the vessel is being heated, it is rotated around its horizontal axis in order to ensure heat is appropriately distributed to the different areas of the vessel. The carbonization process takes about 30 minutes after reaching the designated temperature. During this time, both pressure and temperature are constantly monitored. MSW is usually made out of food, paper, wood, plastics, glass, and metals. Metals and glass remain intact while the other components are transformed into high-purity black carbon. Around 70% to 80% of MSW organic material, so excluding metal and glass, is made out of water. As you can see, during the carbonization process, water is ejected from the vessel as water vapor through a long exhaust. Due to the pressure inside the vessel, when water vapor is being ejected, it carries with it a minimal amount of carbon powder, which can be collected with the help of a simple filter fitted on the exhaust. Upon the client's request, the ejected water vapor can be collected and stored in water tanks to be used later on. Once the carbonization process is complete, cold air is circulated in the outer membrane of the vessel with the help of 2 air turbines in order to cool the vessel and the carbon residue. Other cooling methods such as cold water serpentines can be used. This will also depend on the client requirements. When the temperature reaches 100 degrees Celsius, the vessel is depressurized and the door is opened. The black cloud you observe is due to the resulting carbon particles being carried by the air coming out of the machine. For commercial use, alternative unloading mechanisms are available to meet the client's needs and avoid any possible loss of carbon. For example, the carbon powder can be collected through a vacuum system and stored in special containers if the client wishes to sell or use the carbon at a later stage. As you can see, about 20% to 30% of the initial weight of the MSW placed inside the vessel is now transformed into a high purity, very fine carbon powder. Based on the tests we have conducted, the calorific power of this carbon is higher than that of petroleum coke. To prove that metals and glass don't get carbonized, we did not sort them prior to loading, and as expected, they have remained intact and can be easily sorted from the residue. Sorting can be done manually or through tumblers and magnets, which automate the sorting process. If you have any questions, please do let us know and we'll be glad to get back to you as soon as possible. We hope you enjoyed this video demonstration and we thank you for your time.